what a solution to a system looks like. Right. The solution to a system, so a system is like two shapes, right? The solution to two shapes are where they have the same points, aka where their points intersect. Right. So the first one, notice that it intersects in two places, right here and right here. So that first graph has two solutions, right? Because it intersects at two places. Right? Oh, I didn't even do the top part, did I? Okay. The solutions are where the functions are both true, aka where they intersect. Yeah? So for example, in this first one, the point 0,3 will work on both the line and the parabola, right? Over here, this one only intersects at one point. Think about the geometry. When it touches at just one point, as a T word. Tangent. Yeah, I remember when a line was tangent to a circle, blah, blah, blah. Yeah. So this one, a line is tangent to a parabola. It's tangent to a parabola. So there is one solution. The thing is, though, when you have a line and a parabola, it can cross as many as two places. So there are always going to be two solutions. This happens to be the same solution twice. So when you see a one solution for a line and parabola, this is also called a double root. Yeah, and I'm only bringing this up now because it's going to come back up again later. A double root. Yeah, root, as in a tree. Yeah, not a route. There you go. Yay. All right. For the last one, the two shall never meet. Aww. So there's no solution. It's so sad. Yeah, they'll never see each other. Never. Yes. Okay. Okay. All right. Here we go. Take a look at the next question. How many solutions are there? Two. Definitely two. What are they?
5.
What is it? 0, 6, and 410? Yeah. There you go. 0, 6, and 410. Notice that since it is two equations, one is a parabola, one is a line, the solutions are coordinates. You just got to give me the coordinates, so both the x and y coordinates. Otherwise, it doesn't make any sense. Yay. Yay. All right, let's do this by hand.
No, thank you.
Yes, please. Okay. Here we go. You're going to thank me later because you're going to take that IB test and you're going to have to graph stuff by hand and I'm going to be like, oh, thanks, Miss Fleck. I know how to do this. Yes, there's a no calculator portion of the IB exam. The first paper is no calculator. All right. Here we go. Yes.
They make calculators for
because they want you to understand the concept. So they're not going to give you crazy numbers, but can you do the concept? Yeah. Yeah. All right. You have been warned. All right. Here we go. I'm going to give you a pretty thing, a graph, because I want you to draw an accurate graph on it. Don't just graph it on the calculator and fudge it. You know how to do this. Here we go. The first one is a parabola, so I need the vertex of this parabola. Okay. Here we go.
Wait, it's a -6 over 2.
Yes, x is going to be -6 over 2 times 1, which is -3. Yay? And then the y is going to be plug in -3. So -3 squared plus 6 times -3 plus 9 gives you a number. 9 plus 9 is 18 minus 18 is 0. It was that easy. All right. So you know how we had all that stuff in class? Let's just say the vertex for that parabola is -3, 0. Let's keep it like that. So use space. We'll use that space. Yay? Okay. Graphing that into your calculator, go ahead and find me 2 other points. I believe in you. Oh boy. Say it if you know it. Yes, Jackson.
-4, 1, and -2.
Sir, you are a genius. -4, 1, -2, 1. Sweet. All right, let's graph this parabola. Here we go. It's in your -3, 0, -4, 1, -2, 1 looks something about like this. Sorry, I went over the graph. Oh boy. Oh my gosh, why are we talking about coughing blood? Here we go. The second equation is a line. From that equation, tell me 2 things you know about that line. Yeah, the slope is 1 and the y-intercept is 3. So, if we plug in the 3, and we know the slope is 1, 1, 1, 1, 1, follow it all the way down. Notice what happens. It crosses how many times? Twice. Yeah, it crosses twice. Once right here and once right here. So what are the solutions? Not a double root.
Oh wait, oh my bad.
-2, 1, and
-3, 0.
sir, you are right. There it is. See, you don't need a calculator. Yeah, the calculator will do it for you. It has that trace button. But you're smarter than the calculator. Do the trace, blah blah blah. Yeah, it'll do the same thing. Yeah. But this is calculator appreciation day. Like, we appreciate you, calculator, because this is a lot of work, isn't it? All right. Not buying it. Okay. Let's do it again. Here we go. Let's do it again. This time, right? We're gonna do the Under Armour thing, right? So one parabola going this way, one parabola going this way. Take a look at it. Yeah.
Wait a minute.
Yeah. All right. Here we go. Yeah. 2 parabolas. 2 parabolas because it's beautiful. It's beautiful. Oh, it's not? No, it's not. But I have tissue for your issue. Here we go. All right. Here we go. This is number 1, right? This is, I'm gonna put graph number 1 in that bar. Yay. All right. Here we go. X is equal to -b, so 4 all over 2, 1, which is 2. Yay. And then y is equal to 2 squared minus 4 times 2 plus 5, which is 4 minus 8 plus 5 is quad. Right. So this first one will have a vertex of 2, 1. Yeah? Okay. Still working on that first line. Give me 2 more points. 1, 2, 3, 2. Yeah. Am I going too fast? I'll slow down. Good. I'll slow down. Let's graph it one thing at a time. Okay. The graph. P.S. If you want to use your highlighter as a opposite writing tool for the second graph, do. All right. Here we go. Vertex is 2, 1, and then 1, 2, and 3, 2. So, does your graph look like that? Yes? No? Maybe? Yeah? Okay. Anybody do the second one yet? Let's do it together. Here we go. Okay. 0 over 2 times -1, which is still 0. And what happens when x is 0? Y is -5. Yeah. When the x is 0, the last one is the 1. True. Because all the x's. Yeah. So that was easy. So this one's vertex. Oh, I forgot to number it. This is number 2. This is graph number 2. I know. Whew. 0, -5. 2 more points. Yeah. -1, -6, -6 or +6? -6, and then 1, -6. What's so sad? Oh! They'll never be together. It's so sad. Zero. Okay. 0, 1, 2, 3, 4, 5. Yeah. And -1, -6, and 1, -6. Oh, sad face. Yay? So this thing has no solution. Joy. Joy. Yeah. All right. Whoa. The next ones are inequalities. Oh my goodness. Oh my goodness. Okay. Here we go. Remember that for inequalities, the type of line matters and where you shade matters. How do you know if you have a solid versus a dashed? Or just the equal to sign, right? Whether it's there or not, right? The less than or greater than part tells you where it shades. If it's greater than, shade up. Less than, shade below, right? Jenny, hey, unless you want to plug in a point just to check your work and do extra work for it. That's all good. All right, here we go. Same thing as always. The first one's easy. What's the vertex? What's the vertex? Yeah, it's literally, because that's also in vertex form too, because it's just x minus 3. So this one's vertex is going to be at 0, -3. Hello.
She's never okay.
Right? So is that 0, -3. The points are
-1, -2.
1, -2. Now, because this thing is greater than or equal to, this will have a solid or dashed?
Solid.
Right. This one will be solid and then shade
Above.
Yeah, above. Okay, so solid and then shade above. Okay, here we go. Let's graph the first one. 0, -3 is over her. Yeah. -1, -2, and 1, -2. Solid line. Right? And the shade shall be, I'm just going to go like this, above all those points. So it's going to be in between that absolute value. Make your lines go all the way up so you can see. Just keep on extending it. Yeah? Okie dokie. Here we go. Ah! Oh boy. All right. That was number 1. Yeah. Number 2. Okay. Number 2 looks something like this. It's not in vertex form. No big deal. X is equal to -4 over 2 times -2, which is 1. That's 1. Okay. Y will be -2 times 1 squared plus 4 times 1 plus 2. So that's -2 plus 4 plus 2. How about this? -2 plus 2 is 0. So it's just 4. Yeah. Okay. So my second one's vertex is going to be at 1, 4. 2 more points. 0, 2, 2, 2. Excellent. Because it's a less than, just a less than, the line will be dashed. Right? And then shade.
Wait, it should be negative.
Isn't -2?
Oh, it does. Still a point above. Oh, I thought
Yeah.
it was -1.
Oh, yeah, no, it's +1. Yeah. Less than shade. Hello? Below. Okay, here we go. Let's graph this puppy. It's so easy though. 1, 4 is here. 0, 2, and then 2, 2. Okay. Watch your lines. This one has to be dashed. Right? And this one is shade below. Like so. Okay. Here's what your highlighter's for. Ready? The solution has to be where the two U's intersect. So it's right in the middle where they intersect. So take your highlighter, if you have U's already, or just shade it in like really hard with your pencil. The solution is this area right here. Right? Yeah. Okay. AKA the area where the two shades meet represents the solution set. Okay? In other words, any point in that shaded region is an answer to both of them. Yeah? Give me a point in that shaded region. It's the easiest one. 0, 0. So if you plug 0, 0 into both of those, it will be true for both cases.
Well,
Yeah.
how it has like the second problem is root is less than, or greater than, so the number will be less than.
So when you plug it in, right, when you plug in 0, 0, when you simplify that equation, it will be true. So zeros would be like 0 is less than something. So it's going to end up be, for number 2, if you plug in 0, 0, let's say, right? This would be 0, and you put in 0 for the x's, then those go away. So it just be 0 is less than 2. Is that true? Yeah. Yeah, and over here, 0 is greater than or equal to -3, also true. Yay? Yay. All right. The solution is what? Oh yeah, just on the graph. Since it's an area, there are an infinite amount of solutions. So every point that's possible in that graph is a solution. So we're not going to list it all. Yay? Okay, here we go. You shouldn't have any homework tonight. It's just practice. Just practice. Can you do this, I don't know, 8 times? 8 times? Okay. Work together, and then when you're done, just turn it in.
Wait, you said that we have no homework.
Are you want to give me a case of Vito?
I mean, I like took a bite out of it.
I want to buy you.
Can you throw that in there?
No.
Oh, no, or you should be chunks. Oh, I can do that.
There you go.
I'm sorry, I stared at it for a long time. Why is he randomly making it? Not You're fine.
Oh!
Wait, Abby, did you get one? It's like this.